Hey guys, Buildzoid here, and this is just going to be a very quick video to hopefully demonstrate on camera a thing that I've noticed with the Z790 Aorus Elite AX motherboard on the F3F BIOS, which is that this board really seems to hate high memory voltages. So right now I'm using the exact same memory settings that I was using in the previous video about the stable 6400 CL30 overclock with this motherboard with some single rank Hynix MDI. And basically what we're going to do is we're going to bump up the voltage, see what happens. Because in theory, or at least, yeah, in theory, this should just immediately stop being stable. And this has passed like a ton of Y-Cruncher, LinPack, HCI mem test. Like every stress test I've thrown at this passed with these settings that I have here right now. So we're just going to quickly scroll through them, so if anybody wants to compare against the video with the stable overclock, that, I didn't change anything. Because I literally just started recording the video this video right after finishing recording the previous video. Anyway, 1.35 volts VCCSA, 2 volts VCC in, 1.4 volts on the memory, on the memory controller. Are they memory? Yeah, memory controller voltages, and then 1.45, 1.4 on the memory. And what we're going to do is we're going to punch this to 1.5 and this to 1.55, and in theory the stability will go to hell. And we're going to set this to 1.5, and this is a sort of gigabyte approach or gigabyte-esque approach to the voltages where VDD2 and memory VDDQ being the same tends to work pretty well. I might be wrong with this board, but actually, you know what? Let's leave VDD2 at 1.4 volts first. Let's do it first that way. The board has a safe boot. If it doesn't train, then not a big deal, right? I have that enabled over here. But anyway, yeah, CPU settings are the same, 56, 48, 48. No E-cores turned on because the E-cores get in the way of the memory stress tests. And then we have the AVX offset set to 1. So, we'll save and reset, and in theory, I shouldn't be able to run basically any amount of VST. That's the main thing that I'm expecting to see is we're going to get into Windows, I'm going to start Y-Cruncher VST, and it is going to crash very quickly. And if it does, then it confirms that this board really hates high memory voltage, which is kind of annoying. And kind of interesting, and well, it's and this is a general thing with DDR5 is just, because the memory speeds are so high, you really do start running into issues with raising the voltage actually ends up just distorting the signal instead of making it go faster. So, yeah. There's a really, the most extreme example I can think of for that is that when I was doing my max DDR5 memory attempt, max DDR5 memory clock on 12th gen with liquid nitrogen, I ended up hitting the highest memory clock I could with 1.35 volts because any higher voltage was less stable. Also, the board is taking forever to train. So it looks like this might already not be working. Okay, no, it looks like it made it. Did I disable memory training? Did I leave fast boot disabled? I think I did. Oh, yeah, okay, everything booted. Yeah, fast boot is still disabled, so... Actually, what we're going to do now is I'm going to enable fast boot so that we skip the memory training. I don't feel like going through it again. It literally just trained. It should be fine. If it now passes VST, I'm going to be very upset. I'm going to be very, very, very upset because it's not supposed to. Because if it does, then that means there was headroom for lower primary timings. There isn't headroom for more speed. Because yeah, the board really seems to hit an absolute brick wall with MDI at 6600, and at 6600 1T command rate doesn't work anymore, so not worth the effort. So that's not worth it. Anyway, we're gonna do 8, 18, and let's just go for it. I'm not gonna set a time limit because I don't think it's gonna make it past 2 loops. Yeah. Yeah, it absolutely hates voltage. Like, for comparison, I'm gonna just drop the memory voltages now, and we're gonna see what that does. And this is a very real thing that you have to be aware of with DDR5 is like it rolls over really hard, really fast. So we're gonna turn on the memory training again, because I do want it to retrain, right? Like if we don't retrain, then potentially the memory controller is just doing things wrong. Yeah, like this would be really cool to see with a like if I lived in Fantasyland, I would have an oscilloscope that is capable of measuring DDR5 data signals, or well, actually, the issue is I'm not sure what part of the memory bus is like getting screwed up, because it could be the command address bus that like starts having distortion issues at high voltages. It could also be the data queue that's having issues with the high voltages. But yeah, in Fantasyland, I would have an oscilloscope that can measure 6.4 gigabit per second data rates and like data signals, which means you'd be looking at like probably like a 10 gigahertz plus bandwidth of oscilloscope. Yeah, something like that. And then you could actually monitor what the waveforms look like. So you could actually see that as you raise the voltage, the waveform just gets like scrambled on something. And it might be everywhere actually. Like it could be both the command address bus and the data queue getting screwed up. Did I forget to disable fast boot? That rebooted way too quickly. I mean, the easy way to, like, if now Y-Cruncher runs, then it doesn't even matter if it didn't retrain, because that alone is going to tell us what we need to know, right? And 0. Unfortunately, VST takes forever to run. But yeah, this looks like a pretty clear-cut case of you raise voltage, stability goes to hell. I really, really wish I knew what's actually happening. Like, I think it would be so cool to see the signal. Because I am like, it has to just be distorting, is my guess. Because I can't think of any, like, it's not like these memory sticks have issues with high voltage. Like, I've done 1.55 volt overclocks with these on other motherboards without any issues. With Ryzen, actually no, Ryzen I've had issues with the boards that I have don't support the power management IC on these sticks properly, so I've not been able to use high voltages with them yet on Ryzen. But yeah, I'd love to see why it is that like if you bump the voltage on this motherboard to like 1.5 volts on the memory controller just goes like, oh, I don't know if this is a 1 or 0 anymore. Like I can't read this data anymore. Because yeah, like it just seems to be running right now, which is what I'd expect. Like this is supposed to be stable at these settings. So yeah, this is just a very quick demonstration of like with DDR5, unfortunately, more voltage does not always equal more better. This is not the first time though. There's DDR4 memory chips like say Samsung 8 gigabit C die where if you shove more than 1.35 volts into it, it just basically stops functioning, especially at higher speeds. Like at 3600 CL18, it goes from stable at like 1.3 to 1.35 volts, and if you shove like 1.45 volts into it, it is horrifically unstable. So yeah, this isn't like totally new, never before seen behavior. It's just way more common with DDR5 than it was with DDR4. And it also seems to be more tied to the actual motherboard than it is to the, well, like to some extent, it's going to be tied to the memory chips. Like there's just going to be memory chips out there where if you shove too much voltage into them, they stop functioning correctly. But it's interesting that even memory chips that work at very high voltages don't work at those high voltages on all boards, right? And again, DDR4 did do that. Just like you didn't, it wasn't noticeable because it doesn't really start being much of a factor until you're in very high speeds. Um, yeah, like Samsung 4 gigabit eDie, if you're pushing it from max frequency, will generally run best at like 1.5 to 1.65 volts. But if you're pushing it for max performance, or at least lowest memory latency, it runs best all the way up to like 2.1 volts, right? So yeah, like this isn't new and like unseen, new behavior that I've never seen before. It's just way more common than I'd expect it to be. Because with DDR4, like, you kind of had to try to end up in this situation where, like, raising the voltage causes mass instability. But with DDR5, it's just like, yeah, you get a certain board, you raise the voltage, it's just like, whoa, it doesn't work anymore. Which is probably just, a result of the fact that the data rates are higher than ever before, and so the signals are, like, the signaling requirements are much more sensitive than ever before, but it's annoying. Anyway, I don't think we all want to watch VST for like 6 minutes. So that wasn't immediately crashing. So the next thing we're going to try bump VDD2 and you know what? Screw it. We're going to bump VDDQ as well. We're going to set everything to 1.5 volts. And I think it's still going to crash immediately. At least it should crash immediately because, yeah, like it's a very... Like, from my testing when I was trying to set up the 6400 CL30 overclock, it's a really clean breaking point of, like, you go much over, like, I didn't test, like, 1.425 volts. I didn't go in 10 millivolt increments. I think that's ridiculous, but I did go in, like, 50 millivolt increments. Also, I did disable fast boot. It's taking way too long to turn on. Yeah, like, I'd go in, like, 50 millivolt increments, and basically at, like, 1.45 volts, it doesn't work anymore. So if we set 1.5 volts to everything, it won't work anymore. We can get away with slightly higher VDD because the VDD isn't, as far as I know, the VDD voltage itself isn't used directly for driving the data queue from the memory chips to the memory controller. But then, like, VDD2 and VDDQ, like, those are the two voltages that, like, the CPU and the memory sticks use to talk to each other, and so if those are slightly too high, they stop being able to understand each other. 1.5. 0.5. Would also be cool to see what the actual, like, signal looks like specifically from running VST, because, like, I do, like, why is it that VST is so hard on memory stability, right? Like, that would be interesting to see, but unfortunately, the oscilloscopes that measure DDR5 level signals are hundreds of thousands of dollars. Yeah. I really do hope it just crashes instantly again. I don't really feel like waiting for it. I'm not very patient. Let's go. Crash, 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 crash. It's lasting a lot longer than I expected. Yeah, way longer than I was expecting. How is it still running? I wonder if it's because maybe because VDDQ is at 1.5 volts now? I unfortunately don't know what exactly the VDDQ voltage is used for. Like, I do know that it's internal to the CPU. and it stays inside the CPU, but I don't know exactly what it's for. The Intel documentation isn't like, it doesn't say, hey, this is literally why we have VDDQ. If I had to guess, it's probably like related to like memory controller to system agent connection. So I wonder if I lower the VDDQ now, if it's just going to stop being stable again. This is really annoying. Okay, well, that doesn't seem to be super unstable immediately, so let's break it again. Right, because it's like the main thing with setting up any kind of overclock, especially a memory overclock, is like figuring out why it's breaking. Right, having things that are stable and you can't tell, like, if you don't know how to break the stability, then you don't know how to achieve the stability either. Right, if you don't know why sometimes it doesn't work, then you don't know why it does work. So I'm kind of I kind of suspect it's the VDDQ voltage, which is annoying because really high VDDQ voltage is not really a good idea for long-term use. Like, I wouldn't daily it higher than 1.4 volts. So that's still, I mean, 1.45 volts. So that still isn't, you know, like, so if you need like 1.5 volts VDDQ in order to run 1.5 volts on the memory, that's not great. That's really not great. And that would actually align with some of the behavior I've seen on, like, say, like my Z690 Apex, for example, requires VDDQ to be equal or greater than the highest memory voltage. So, yeah. I really hope it's not like this board isn't just exhibiting that exact same behavior again. It's not impossible. Because the thing is, there are motherboards out there where you can have like VDDQ at like 1.35 volts and have arbitrarily high other memory voltages, and it doesn't cause any issues. But I'm not aware of why that is, unfortunately. It's just like some motherboards don't really care about VDDQ, and some motherboards care entirely too much. So let's see if this one is one of those boards that cares entirely too much. Or maybe it's just an issue of having like... Wait, no. 18, 0. Huh. So maybe it doesn't like high VDD? I wonder if I could just raise everything to 1.55 volts. And if it would still not crash. Because, like, I did demonstrate that 1.55, 1.5, 1.4 definitely doesn't work. Which wouldn't be that surprising. So maybe 1.55 across the board is fine, and it's just like it doesn't like it when they're not all the same. As in 1.55 on VDD2, VDD, VDDQ for memory, not CPU VDDQ. I really don't like the fact that there's two different VDDQ voltages on this platform. To be like, and what's funnier, arguably, is that this isn't the first time that Intel has done this, where there's like two very different voltages on a platform that have the same abbreviation. On X58, you have like, I'm pretty sure it's X58, where you have like DRAM VTT and also CPU VTT, and they're like not even remotely closely related to each other. One of them is like memory controller voltage, and there's a bunch of motherboards that don't even refer to it as VTT. And the other one is like memory termination voltage. Okay, let's try 1.55 across the board. If that doesn't immediately crash, then that means it might be possible to do like CL28 at 6400 with this board. Not that that would make a major performance difference, but, you know, it would be kind of cool. Memory training is taking a while. I really wish this had a post code. But it does produce like a bit of coil whine as it's going through memory training, so you can kind of tell like when it's about to finish because you can hear it. Okay, I think it's upset about this. It's still stuck on memory training. And it's making the coil whine noises again. So I think it's looping through memory training now. Okay, it finished memory training, and I bet it's going to crash Y-Cruncher. So maybe there's just like, it doesn't like more than 1.5 volts, which kind of sucks because, well, 50 millivolts more probably isn't enough to push you from CL30 to CL28. Like, the amount of extra voltage you need for 2 ticks of cast latency gets disproportionately bigger as you go, like, as you lower the cast latency. So we're going to stress testing again. We're going to go disable everything but VST. And go. Huh. Oh, there we go. Okay, so it just really, really doesn't like 1.55 volts. Interesting. Oh, whoa, it really doesn't like 1.55 volts. It actually took the whole system down now. Very interesting. Yeah, so anyway, I think that concludes this video, because this is pretty much all I really wanted to show is like with DDR5 on some motherboards, the voltages have, like, even if you have memory sticks that like tolerate a lot of voltage, I guess most people don't have the issue of like, oh, I have 5 different motherboards that I've used the same memory kit on, and on like 4 of those boards, that memory kit works at like 1.6 volts, and it's great. It does super low timings, and it's amazing. And then there's like this one motherboard where it literally doesn't function at 1.55 volts. So that's not really a regular problem for people to have, but yeah, this is something worth noting with DDR5 is just like, yeah, you just can't keep raising the voltage on all boards. Also, this behavior can change with BIOS revisions, which makes it worse. Because it's like, oh yeah, it didn't work with this voltage on whatever BIOS, and now on some newer BIOS, it's like, oh yeah, you can run like way higher voltages and it's still stable. Anyway, I'm just going to safe boot it because it's taking way too long to train memory again. So, yeah, that's... Man, I don't want to outro the video on the freaking capture card, like, no signal screen. So we're going to wait for the board to get back into the BIOS, and then we're going to end the video. Oh yeah, like, this is a pretty clear demonstration that the F3F BIOS on the Z790 Aorus Elite, and probably all of the other 6-star daisy chain gigabyte motherboards, so like the MATX Elite, if there's a Pro, then the Pro, there isn't a Pro. Why isn't there a Pro? Gigabyte Z790 lineup, now that I'm looking at it, looks kind of unfinished. But basically, yeah, like, I think from this, it's kind of clear that the 6-layer daisy chain gigabyte boards don't particularly appreciate high memory voltages. Also, it's taking forever to train the memory in safe boot again. Actually, I think the safe boot on this board is just kind of slow in general. I mean, now I'm just making the video longer for no good reason because the board won't post. The thing is, I didn't set up the camera pointed at the board, like to have the board on screen, so I didn't really think this through very well, did I? I think the safe boot might have failed. It does sometimes do that. Or maybe I'm just bad at using it. Okay, there we go. Okay, I think I might have just, like, reset the board instead of using safe boot, because... Come on. There we are, yeah. So, anyway, yeah, this is something to keep in mind with the Gigabyte Z790 Aorus Elite AX. Don't just mash more memory voltage into it, because you actually, like, you'll potentially end up making your stability worse. And I know here I've, like, demonstrated a sort of extreme scenario where we're going straight from, like, 1.4 volts, which works great, to 1.55, which does not work at all. But I think if we were, like, if you were trying to run Y-Cruncher for longer periods of time, I think you'd probably find that even at, like, 1.5 volts, it wasn't necessarily stable, right? Like, because, sure, it didn't crash in the first 2 minutes, but, like, I've had Y-Cruncher crash, you know, like, 15 minutes into the test, 20 minutes into the test. I don't think I've had it crash at 30 minutes into the test, but, like, it can crash pretty late into the test if your memory is like very slightly unstable. And so that's why I run VST for over 3,000 seconds, right? Because that's like 50 minutes. And yeah. And so in this, like, very quick demonstration, I mean, I can't really, you know, show you that, like, well, I don't think the 1.55 volts is actually viable. I mean, well, 1.55 is definitely not. That crashes instantly. But 1.5 I don't think is viable either. 1.45 might also not work. And 1.4 works. 1.4 definitely works. That passes all of the stress tests. But yeah, so this is just sort of something to keep in mind with the DDR5 tuning, is that you just can't mash voltage into things, because at these super high, you know, data rates, more voltage sometimes translates into less stability. Actually, I mean, to be fair, it already happened on other memory standards, but with DDR5, it's, like, especially common that you'll run into this behavior, because this isn't even like a memory chip that's notorious for bad voltage scaling, right? Like, this isn't Samsung 8 gigabit C die. This is Hynix M die. This is a memory chip that, you know, on some motherboards people will run it at, well, like 1.6 volts to get really low cast latency at high memory speeds. Like, I think I've seen screenshots of, like, even 7000 CL28 with high memory voltages. And then, you know, if you try to do that kind of thing on a board like this, like, you can't even really run Windows anymore, because it just blue screens at like 1.55 volts. So yeah, anyway, that's it for the video. So hopefully this is somewhat helpful. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp if you'd like to listen to, like, industrial noise, because that's what I make and put on Bandcamp. So yeah, if you'd like to support the channel through that, there's a link to that down in the description below as well. And that's it for the video, so thank you for watching, and goodbye.